favorite subject, as it is mine. All right. And it's counting down. There we go. Okay. So, I know we have limited participants this time, so Marquise, it's all you. So how about this solving the equation?
Seems pretty confusing but easy.
Confusing but easy?
Yeah.
Okay, so try this. Don't worry. It's just you and me at this time until everybody that is not in my class watches it. So see if you can try it, but do you see those little notepads down there? What I'm going to actually do is I'm going to give you some rights, because that's what I'm all about, giving you extra rights, see? And then what you can do is you can actually then type in the notepads in a minute when I maneuver this mouse better. Notepad. Okay, so see if you can try this since you haven't done this before. So see student 1 over there? Are you able to, is that you?
Yeah.
Of course it's you, because I know who's logged in, see, haha. So see, you can type in the notepad. So see if you can type in the notepad the answer to that. And actually, if you want to, some people type in their work too. There's not a ton of work on it, but if you have work, try to type in your work too. Oh, very good. See how fast you are? Excellent. Very good. I can see that you are multiplying by the reciprocal. Nice job. See how you're figuring this out, Marquis? See, I try to do a little warm-up usually when we, see, and now Tanya's going to come in, so you're not going to be all alone. Okay. Tanya, how are you? I'm going to give you some rights so that you can type with Marquise here. Give me just a second. Good. You're doing really well, by the way, Tanya. I just want you to know I will be at Gateway on Wednesday, which is tomorrow. So hopefully, I don't know if you're going to be there, but we can sit down and look at a couple things. But overall, I would say you're doing great right now. Very nice. You're working hard. Okay, good. I'll look for you tomorrow. And remember, we have a late start, so we don't actually start till 10 tomorrow, but I will look for you. All right, so Tanya, what we're doing right now is we're just doing a little warm-up. If you want to try in student 2 to solve this equation, feel free. And let's see, Marquise, what did you get? So you multiplied by the reciprocal. Excellent job. Then you did 6 by 3 halves, 6 times 0, 2, and very nice, very nice. So solving problems is not a problem.
Just got a little confused.
No, you didn't. You weren't confused at all. So, Tanya, what I'm going to do is just kind of go through it. Since Marquis, he already solved it, and we'll just kind of do it together, and you can see what he did, and I'll actually walk through it as well. How's that sound? Good. All right. Good. Okay. So the way to do this, these types of problems, just because you're going to start seeing a lot of fractions, and I just want to make sure you guys have pretty sound skills since you guys are in the advanced algebra, and we are done with statistics for the most part, except for I know that you guys still need to take your test, but you guys both started late, so don't stress about it. But we're going to actually start doing the advanced statistics lesson, or not advanced statistics, advanced math lessons here with just some basic skills. So you won't be doing that yet until you get through your statistics, but you guys are getting close. So anyway, we are going to solve this, we are going to take the reciprocal of 2/3. So we multiply both sides by the reciprocal. So if we multiply the left side by 3/2, we need to multiply the right side by 3/2. Now remember that if you see a number by itself, it's the same thing as the number being over 1, and that can help you when you're multiplying. So 3 times 2 is 6, 2 times 3 is 6. So basically what happens is that 3/2 times 2/3 turns into 1. So you're left with just G on this side, which is what you want. And then on the right side, you have 6 times 3, which is 18, 2 times 1, which is 2, And Marquis, you got it. 18 divided by 2 is 9. So real quick warm up. Any questions on that, Tanya? How do you feel about solving equations? One or two step equations? You feel good. Okay, good. Good, good. Excellent. Oh, Marquis, that's you too. Okay, but Tanya wrote good. Okay, nice job, you guys. Nice job. See, I make those little notepads for you all. Okay, so here's what we're going to do today. Actually, we're going to walk through some basic stuff. Again, basic skills, prerequisite skills. I know I had you guys all take a pre-skills assessment. Tanya, I'm not sure if you took it yet, but don't worry. I believe it's in week 5. I think, Marquise, you took it. And some of the stuff maybe you've seen but you don't remember, and that's fine. It doesn't go against your grade. I just want you guys to know. It's just to kind of help me know what basics we need to go through. So a couple of things we need to make sure we understand are exponents, and that's because eventually we're going to be graphing exponential equations and working with exponents when we do quadratics. So I just want to make sure you guys are pretty comfortable with these. I just want to show you how this works. There's a couple of nuances to think about. So
2 to the third.
very good, very good. So in this first one, we have 3 2's, so it is 2 to the third. And then we have 2 of the 3b's, so it's 3b. And now what I would do, you guys, is it would not be correct to put a little 2 above the b, because otherwise you're only taking b squared. So make sure you put what you're multiplying in parentheses when you have 2 of them. Does that make sense? That's as compared to if you just did 3b squared, that would be this. Exactly, that would be 3 times b, which would not be correct. Okay. So another trick too that you guys probably know about but you're not thinking about is in this case we have a -4 times a +4 times a +4, right? So one thing to keep in mind with this one is that the negative goes out front, and then you put the 4 in parentheses and you have 3 of those. So does that make sense?
Yeah.
Because if in this case, like for example, if you did -4, well, you could actually do it like that. That would be okay. So you could do it that way too. You could say -4 cubed.
Wouldn't it be like 64 since like you're multiplying negatives?
Yep, if you have the negatives inside. So you mean like this? Let me So if you did, for example, this -4 cubed, would that be the same? What do you think, Marquise?
I think if I change this, like it'd be negative times negative.
You're right. You're exactly right. Yeah, that wouldn't be the same because this one would be -4 times -4 times -4. So that one would not be the same. So you're right. So just be careful how you represent it, because this negative, this is like saying -1 times 4 times 4 times 4. So they're just little tricks that students always get confused with, and so just always good to review. So you guys will have a couple of that in this week when you get to it. Compare that to this one. This is pretty easy, right? You have 4 -5's, but the key is you got to make sure that you keep that -5 in the parentheses so that you know that you are multiplying 4 -5's and not something like above where you have a -5 times 5. You know what I'm saying?
Yeah.
So be careful about that. And then in our last one, in this, we have 1, 2, 3, 7x's. So again, keep that in parentheses so that you make sure that both the 7 and the 3 are raised to the 3rd power. And then you've got y. You don't necessarily need a parentheses, but I'm just going to make it look nice. And then you've got your 4ab. And again, on something like that, you've got 1, 2, 3, 4 of those. So each of those is to the 4th power. You've got the 4 to the 4th power, a to the 4th power, and b to the 4th power. All right, you guys, so any questions on simplifying the expressions? Okay, I just want you guys to understand that anything in parentheses means that every single term goes to that power. So like with this 4ab, 4 is to the 4th, a is to the 4th, and b is to the 4th. Okay, so let's reverse it. Let's expand. So in this case, that one's pretty straightforward. You've got 3 4's, so 4 times 4 times 4, and then we've got 2 x's. So that would be x times x. Okay. Okay, and then the second one, You've got a negative out front, but then you've got two fives. So we don't put the negative with each of the fives, we just put it out front. In this case, we've got 3 of this whole thing. So we've got to do 2a times 2a times 2a. All right? Okay, last couple then, and then we'll move on to what we're doing. So negative 6 raised to the 3rd power. We've got 3 of these negative 6's, so that's a times. And actually, you know, it's a little bit confusing when you put in a times and you got negative. So what I'm going to do is write it in parentheses. So negative 6 times negative 6. And then you've got a, and then you've got 4 b's. So b times b times b. A lot of b's. Thank goodness I didn't make that to the 8th power or something. All right, so far so good?
Yes.
Good? Make sense? Tanya, you're good too? I'm assuming? Got a lot of goods up there. I think those might have been from before. Okay, last one then. So you've got 2 x's, so 2x times 2x, and then you've got 2 4y's, so 4y times 4y, and then you've got 3 of these. So again, this is where I would maybe keep my parentheses, just to make sure that people know that each of the terms in here, the negative, the 6, the z, all go to the 3rd power. Okay. Yes, Tanya, good. All right, you guys, so that's it for exponents. Any questions with exponents at all? Anybody need any help with those? Anything like that? Any explanation? Marquise, are you good?
I'm okay.
You understand the difference with the negative in the parentheses versus out?
Yeah.
Okay. That's the only nuance with those. Otherwise, they're pretty straightforward. Okay, so in your lesson coming up when you guys get to this week, you are going to, and it seems kind of weird, and people always wonder, like, what's going on with this? But what we're going to do is learn how to rewrite equations in terms of the variable indicated. So whenever we say in terms of, whatever we're doing in terms of, that goes in the equation. So in this first example, we have an equation for the area of a rectangle. I'm sure you guys have seen this. Area equals length times width, right? We want to rewrite it in terms of a and w. So that means a and w are going to be in the main part of our equation, and we're going to set that equal to L, is what that means. And the reason that we rewrite things is that sometimes we're not always trying to find the area. Maybe we know the area and we're trying to find the length, or maybe we know the area and we're trying to find the width. So sometimes we rewrite this in order to make it easier to solve for what we want. And if you're a programmer, a computer programmer, that's what they do a lot of times depending on what they're trying to find. So basically, you guys, what we're going to do is solve for L. And in order to solve for L, we need to move the W to the other side. So the way to do that is you just divide both sides by W. And like I said, it's kind of strange for people because you're not really solving anything, you're just rewriting it. Okay, so then the W's turn into 1, W divided by W. So we end up with just L for length is equal to the area of the rectangle divided by the width. So if you were trying to find the length and you had the width and the area, that would be the equation you would use. All right, the next one, surface area of a sphere in terms of A. So in this case, we want A to be in our equation, so we want to solve for R. So what that means is we're going to solve for R. The hard thing about saying solve, though, is that confuses people because we're not solving, we're just rewriting. So this one, we need to move that 4 pi to the other side. So I'm just going to divide both sides by 4 pi. Okay. And what I'm left with, in this case, if you think about what happens, the 4 pi divided by 4 pi just turns into 1. So I'm going to be left with r squared on one side, and then area divided by 4 pi underneath. So here's a question for you guys, checking on your old math skills. I haven't solved for r yet, so I need to get rid of this squared. Does anyone know how I would get rid of the squared? What would I do? I said nope, or nope, because that was before. How do I undo that? So you guys know that to undo multiplication, you do division, right? Division, multiplication undo each other. Addition, subtraction undo each other. But what does undoes a squared?
Make it a circle.
A circle? Think about a math term though.
Look for the radius.
We gotta find the radius. But what we want to try to do is get rid of, so think about what r squared is, right? R squared is just r times r. How do we turn that into 1r?
Wherever.
Good, perfect, square root, awesome. So if we take the square root, that is exactly right, of that side, then we have to take the square root of the other side, right? So the square root of r squared just is r. Excellent job. And then on the other side, we're just going to leave it, right? Because obviously we don't have any numbers to plug in, so it's area over 4 pi, take the square root of that. So basically if we wanted to find the radius and we knew the area of a sphere, we could just plug it into this formula and we would be good to go. Okay, final one. In this bottom one then, we are wanting to find the area of the triangle in terms of A and B. So in other words, on this one, we are going to solve for h. So hopefully, for height, yep. Very good, Marquise, very good. Okay, so first things first, just like the warm-up, we've got a fraction. So what I'm going to do is multiply by the reciprocal to get rid of that fraction, which means I need to multiply the other side by the reciprocal as well. So I'm left with 2a on the left side, the 1/2 and the 2 over 1 become 1. Okay, and then I just am left with BH. So if we look at what I was doing, I want to solve for h, so I still need to get rid of the b. So in this case, I'm going to divide both sides by b. Okay, and we know then that b divided by b just turns into our 1. And our final answer then, we have h on one side, and on the other side we get 2 times the area divided by little b. Okay, so I just wanted to run through a couple of those rearranging equations just because you're going to be doing that, and there is a lesson on that too, so if you need to see some more of this, feel free to watch the lesson. Otherwise, if you feel pretty confident, you can just open the lesson because you know you have to view it first and then try the actual assignment. One other reason, and one of the main reasons we're going to be using this now, is actually for this next slide, and that's because sometimes you're going to be asked to graph. We do a lot of graphing in this course with different kinds of equations. We're starting with linear and inequalities coming up, but again, we're going to graph rational and exponential and quadratic. So sometimes you need to be able to write an equation so that it's easier to graph. Okay, so what comes to mind, you guys, and you can write in your notepad, type it in your notepad if you want. What's the equation of a line? Do you guys know the generic equation for a line? See if you can type it out if you remember. Or Tanya, I don't know if I made you, oh, I did think I gave you a notepad. Tanya, do you remember what a generic equation for a line is? Or Marquise? You guys are awfully quiet. It's like the most common one. There's a couple different ways, but it's the most common one for a linear equation.
X plus y, x and y. So I'm going to deal with an x and a y.
There is an x and y, that is true. Good, good, good. There is an x and a y. All right, you guys need some help, looks like, perhaps?
Yes.
Okay, so you guys, does this look familiar? Y equals mx plus b? Ah, yes, the mx plus b. And b is your y-intercept, right? And m is your slope. That's kind of easy to graph because you just plot your y-intercept, and then you take your slope, and that helps you to graph your next point, right? You go rise over run, make a point. But if you look at what I gave you guys, 3x plus 2y equals 8, how would you graph that?
3 being the x, y being the y, or 2 being the y.
Yeah, well, it's kind of confusing, right? Because like, what's your slope and what's your y-intercept, and we haven't really solved for y. So this is where we rearrange, right? So we have this equation for a line, but we want to write it in terms of x. So in other words, have it look like this: y equals mx plus b. So all we have to do is solve for y.
Y equals 1.
Exactly, y equals. Okay, so if I do this, You guys stop me if I'm doing this part too fast, the solving, but assuming you guys are pretty good with this, right? You subtract 3x from both sides, and you would get 2y equals, and I'm going to write the negative 3x first so that it looks more like our y equals mx plus b. And then our final step is to divide both sides by 2. And okay, you guys, really quick, I want to point out, if you divide one side by 2, you can divide the other side by 2, right?
Right.
Okay, but you can't just divide only this term by 2. You have to divide every
part.
Very good, Marquise. Every part by 2. But people tend to forget that, and then they get the wrong answer. So 2 divided by 2 is gone, canceled. And our final answer then, we have y equals, and then you can see our slope is negative 3/2 x, plus our y-intercept is just 4. 8 divided by 2 is 4. So you guys can graph this, right? Y-intercept is 4. And then our slope, we have a negative slope. We go down 3 over 2, down 3 over 2. And that's how we would graph it. That's kind of nice. That's easy to do. Set up like this with the x and y is much, much more difficult. Uh-oh. There we go. My screen went off. All right, so in this final one then, we would do the same thing. Pick a fancy color. How about green? We're going to move the 12x over, which means we have to move it to the other side. And then we are left with 7y equals 12x plus 14. Divide both sides by 7. And remember, divide every term by 7. And we are left with y equals 12 over 7, which is our slope, plus 2. Good. Okay, and then that's what we would graph. So that is one of the reasons why we go ahead and rewrite, just to make it easier for us when we're graphing. And you guys will actually be rewriting quadratics eventually into different forms. There's multiple forms for graphing. There's an intercept form, there's the vertex form, and we'll see that soon. All right, any questions on rewriting?
Nope.
Nope. Tanya, is that not? Nope. Okay. All right, you guys. Well, what I want to do is just kind of wrap up and talk to you guys about a couple things. So you know that in your last week, those of you guys who actually took your tests, by the way, which good job on the tests. And also make sure anyone who hasn't taken the test that you finish all the week 2 through week 4 material before you take your test, just so that you're prepared. Anyway, make sure you get caught up. And now like I said, we're starting the advanced algebra. So make sure you work on your math every day. Don't take a day off, because otherwise you kind of get behind. Because typically in math we have several practices every week. So if you don't do math for a week, then it really stacks up. Also, check your grades on Infinite Campus. Those are your real grades, right? Schoology is not your real grade. Did you know that?
No.
Okay. I can show you if you haven't done it. You can look at it. Okay, I'll show you how to do that too. But Infinite Campus is where your eligibility goes, where your quarterly grades will go, which, by the way, the first quarter wraps up in 4 more weeks. So really focus on your math. Make sure you get through that first unit. But again, you guys that started late, I'm going to work with you guys. So I'll make sure that you do what you need to, and then you won't be penalized for coming late. But everybody else should be beginning Unit 2A. Especially if you've already taken the test. And if you've done horrible on the test, then I'll contact you or send you a note and we'll talk about that. But so far, so good. It looks good. Everybody's looking good. So basically, stats has ended and advanced math has begun. And I'm leaving you guys with the final cartoon in the end. Marquise, you have a question?
Yes.
Okay.
Can I go to the restroom?
Yeah, sure. We're pretty much finished. So if you're done, you can go, and you guys all have a rest of the good day. And then Tanya, hopefully I'll get to see you tomorrow. Are there any other questions from anybody? All right. Great. Well, thank you very much, and we'll talk later.